Hello everyone. Today I will be talking about how we can do hypothesis testing. It's about the means and proportion. So in lesson 7 you will see that we gave you lots of examples and then how you can perform some hypothesis testing. But at first, what is a hypothesis testing? What we are doing in the hypothesis testing? Previously you learned about sampling distribution, and then you learned about how we can do point estimate, how we can do interval estimate. We will be using all those knowledge, the methods we learned in the previous modules. We will be applying them in here, because most of the time you will see that we are going to use the sampling distribution. We are also going to use the T table, Z table. You use them before, so we will be using them in here, and we will be working on today on testing on means and proportion. To do the hypothesis testing, at first we need to know what are our objectives in hypothesis testing. Let's say you are interested about what might be the population mean. Let's say in BC, British Columbia, what is the whether the population income in British Columbia among the working group is some amount or not. Let's say you have that question, but we cannot say that what would be the amount. So based on some information we have, we can make an inference about the population. So it's all about the population. We are making the inference. But the thing is, you have to use the sample data so that you can say what might be in the population. We are using the sample data, but we are making inference about the population. That's why it says that you can see, does a population mean equal to 100? We never say that what does the population mean equal. That's another methodology we have to use. But our concern, our objective is here to make an inference about the population parameter. So we are making inference about means or proportions, and then we will also try to see if we have the difference between means. That means if we have two population groups. You saw that previously we were working on difference between two population means and then proportions, and then we were making inference about them. But in here we will also going to use them for hypothesis testing. So in hypothesis testing for mean and proportion, or maybe two means or maybe two proportions, we are going to use this test statistic. In this test statistic, you will see that at first we have to use the sample value. That means, let's say we are talking about the population mean, whether in our class, so if we have the entire data set in the midterm exam, whether the mean grade, that means the population mean, is 82 or not. And then we can test that. So we can say that, let's say we have the data set, and then we have the population value, and the population value is coming from the population data. So let's say we are hypothesizing whether the population mean in our class is 82 or not. We took some sample. Let's say we took 10 students grades, and then we found that using the test, using the sample, the 10 samples we used, the sample mean is, we found, let's say 81. And then this is the population mean. And then the standard error of statistics, that means the standard error of this mean, the statistic, we have to use that. So that means at first we have to use the sample value, population value that we are hypothesizing. This is coming from our hypothesis, what we are saying about the population, and then standard error of the statistic. Okay, so that's what we will be using for. You will see that for z-test, for t-test, for proportion, we are also going to use that. Also for the differences, we will be using this statistic. But then again, whenever we have the proportion, we have to change it to proportion. Whenever we have the difference between means, then we have to change it to difference between means. I will walk you through all of them one by one. In hypothesis testing, our first step is to define the hypothesis. So you will see that there are two kinds of hypothesis. One is the null hypothesis, another is the alternative hypothesis. The null hypothesis we write down by H0, or sometimes you will see that H maybe 1 and 2, or this is the basically we write HO or H0, you can say that. H1 or HA is for the alternative hypothesis. That means whenever we are rejecting the null hypothesis, we are basically saying that we are actually going to use this one. That means this is rejected, and then we cannot say that it's actually is 68. We can say that it's not. It could be less or it could be more. So that's what we say whenever we write the null hypothesis. Then you have to say that either it's actually some value, or it could be value 0, or if we have two population, then we say that the difference between two population mean is 0. That means they have no difference at all. The opposite, the alternative, would say that it's actually not 10, or maybe less than 10, or greater than 10, or less than 0, greater than 0, or let's say if it is not equal. If it is equal, then we can say that it's not equal. Based on your hypothesis, then we can proceed. So you can read all this text. I'm basically going to here. So over here we say that the steps we have for hypothesis testing is that you have to state the null hypothesis first. That means what we are saying about the population. So you will see that we gave you an example. We say that the average weight of 36 students, we randomly actually selected them, and then we are saying that using the maybe we want to make an inference whether in the population the average weight is in the population is 68, and then maybe we are saying that it's not 68, but we don't know. So we have to use some sample data, and then using that sample data we say that we took some sample and we found that it's actually 69.5 in the sample. So is it going to be whether we can say what we can say about the population using the sample data? That's what we are going to test. So you will see that previously we learned about central limit theorem, sampling distribution, all those knowledge, all those methodologies we will be using in here. Okay, since we have the larger data set, also we know in our data set what will be the standard deviation or the variance from the population, then we can easily use the z-test, because based on whether the population standard deviation is known or not, or how was the sample size, since sample size is larger, then we can say that we can use the z-test. So in the z-test you can think about, since we are saying that it's 68 or 68, not 68, that means it could be 67 or less, or more, maybe more than 68, that means maybe from 69. That's what we are showing in two sides. That means we are basically talking about both sides. So if we are talking about, let's actually draw in here. So if we are talking about both sides, that means the 68 is in the middle, and then whether it's 68 or not 68, that means the either sides, it falls on either sides, then it's not equal to, that means it could be more than or it could be less than. Or if we say that nope, I'm only interested about one side, that means 68 is here, or I'm saying that null hypothesis is 68 equals 68, and then we are only testing that it's actually the alternative is less than 68. It doesn't necessarily that you have to go for two sides. I'm saying that could be one-sided as well, or we could test only one side. Okay, so it's always a good idea to draw your draw that and then find out what you actually want to know. So you will see that many times we are talking about type 1 and type 2 error. So let's say whenever we are testing, then we say that we made some mistake. Due to our mistake, a null hypothesis should be rejected. You can see the rejection of null hypothesis when it is true. That means it should be rejected, but we did not reject it. Then we call that type 1 error. The opposite we call is the type 2 error. So let's say we fail to reject the null hypothesis when it's actually not true. That case we call type 2 error, because we could make some mistakes. Maybe we have less data set, or maybe the tabulated value we picked is wrong. It could happen, right? So then we could have two types of error. So you can see that based on the character of the error, we call them with type 2 or type 1. Okay, so I would basically show you over here, so you can see that this is all description, but then again it might be better if you start from if I actually talk from here. So there could be three situations, but we can write them together. We can say that it's actually not equal to 68 in the alternative hypothesis. And then we have basically two situations, less than or greater than, right? So it's a two-tailed test. So if we are talking about only one of them, then it's one-tailed test. If we're talking about both, that means not equals, we are talking about two-tailed test. So you will see that in our assignments, we are also going to sometimes give you one-tailed test, sometimes give you two-tailed test. So at first you need to state what is the hypothesis. That means the hypothesis we had was equal 68, non-equal 68. And then you have to choose the statistics and appropriate alternative hypothesis. Sorry, we already chose that. The null hypothesis and alternative hypothesis. Then level of significance. Most of the time it's mentioned. If the level of significance is not mentioned, then you can use 0.05. This is usually we use that, or you can use 0.01 as well. That means the let's say what we mean by that. So let's say whenever we have the test, let's say Z test, and then we have two critical regions, and then this side and this side. If we use 0.05, if it is two-sided test, then you have to divide 0.05 probability into 2, 0.025, and then 0.025 on the other side. If it is one-sided test, then everything will go to one side. Or if it is 0.01, you can divide it into 2 and say that if the test statistic fall within this region or within this region, then we are going to reject the null hypothesis. If the test statistic value falls within this region in the middle, then we are going to, or we are not going to reject the null hypothesis. Okay, then we can find the critical region. How we can find the critical region? You can use the the appendix, the critical tables we have in the appendix. You can use that based on T, Z, or other tables. Based on that, we can pick our critical region, and then you can compute the test statistics. The test statistics I showed you at the beginning. You can use that and find the value of the test statistic, and then decide whether you are going to reject the null hypothesis or fail to reject the null hypothesis. Be careful what you say, because we never say accept the null hypothesis or accept the alternative. We always say that reject the null hypothesis or fail to reject the null hypothesis, and then based on the what you found in number 6, then we can make a decision. Let's actually talk about one example. So you can see that in this example we are talking about the Douglas fire, and then we have the average Douglas fire is 10 centimeter, and then we know the population value, and then we are trying to make an inference. We actually use some sample data. Using the sample data set, we found that using the 25 randomly selected trees, and then we found that the mean of those 25 sample trees is 9.2. Okay, so that's why we use 9.2 in here. So this value, this is the population mean, and this is the population standard deviation. That means we have the population data set, we have the population information. So when we have the population information and we are talking about mean, then we can directly use the z-test. Okay, that's why you can see we are using the z-test. Okay, let's state the null hypothesis. At first, the null hypothesis, we say that the null hypothesis, alternative hypothesis, always we have to use the population parameter. Since we are interested about the population mean, so we say that population mean is 10 and population mean is not equal to 10. So that's our hypothesis. So it's a two-tailed test because our critical region will fall in two sides, because less than 10 or greater than 10. Then we chose this level of significance. Since it's not mentioned in the question, we use the 0.05 level of significance. So the critical region we would have, since we are using 0.05 and it's the z-test, then you have to go to the table, and then you have to pick the value. To pick the value, at first you need to think about what would be the value. So let's actually find out what would be the value we need to find. So let's draw that z distribution. My drawing is not that good. So we are interested about the both sides. So that means the 0.025 on this side. So I divided it by 2. That means level of significance by 2 is going here, and the level of significance by 2 is going on the other side. Okay, so the mid area is 0.95. So we basically need to find what would be the z value of this point, and what would be the z value of this point. This point is 0.25, the probability, and the probability in up to here under this curve is 0.975. How we know that? Because this is 0.95 this area, and this is 0.25. So if I sum them, it will be 0.975. That means we need to find the z value in the z table. What is the critical value for 0.025 and 0.975? So we found that the value is minus 1.96 here, minus 1.96, and this value is, the critical value is 1.96, because they will give you plus and minus because they are symmetrical, that's why. Okay, I would like to show you how I find those values. So you can see that I opened the Z table. So in the Z table, I want to find what's the critical value for 0.025 and 0.975. Let's actually draw that in here, and then if I try to find that 0.025, then you will see that so 0.028, that means we are looking for 0.025. So you can see that 0.025, we exactly found that. And then the Z critical value would be 1.96. That means negative 1.96. And then same thing, if you want to find the 0.975, then you will find it somewhere down below. Okay. So that's why we are going to use these values over here. Okay. So these are coming from our Z table. And then you can see that in the Z statistics, we actually added the sample mean, population mean, divided by standard error of mean. So standard error of mean, you saw previously, standard error of mean would be the population standard deviation, population standard deviation divided by root over n, the sample size. So that means the 2.5, we saw that in the data set, and then 25 samples we used. So that's why the standard error of mean we divided by that. And then we found that this is minus 1.60. Okay, let's clear everything. And then we found that value. But in our Z, using the Z values, we found that the critical points is 1.96, and then this area is where we are not going to reject the null hypothesis. If it falls somewhere here or somewhere here, then we are going to say that we are going to reject the null hypothesis. Okay, so we have regions, we divided them. So my question is negative 1.60, where it falls. Negative 1.60, we have to figure out where it falls. So you can see that negative 1.96, positive 1.96, and negative 1.60 should be somewhere here, right? So that value would be somewhere here. That means it's actually falling into this region where we are not going to reject the null hypothesis. Okay, so you have to draw the distribution. You have to see where it falls, negative 1.60, and then if it falls between these two values, the critical value, then it means we are not going to reject the null hypothesis. That's why it says that that it falls within the acceptance region, and then we are not going to reject the null hypothesis. That means our sample mean 9.2 is not significantly different than 10. That means the population mean we have, we thought we are not going to reject that. That means it could be the 10 centimeter. So that's how we are going to make a decision and then make a conclusion. So previously you saw that we already knew what's in the population standard deviation. That means population variance was known. But in this case, if we do not know the population standard deviation, then we cannot use T. You cannot use Z. That means the Z distribution we are using before, we cannot use that. And our sample size, you can see that it's small, and then we do not know the population value. That means we are using this sample so that we can actually find the sample standard deviation. That's the difference. So everything is same, only difference is that we don't know the population value of the standard deviation, and then we use the sample. Using the sample, when we do that, then we are going to use the t-test, and then in the t-test we have to use the t-critical values. That's the difference we have. That means you cannot use the z value. So the t-critical value, you see that there is a difference. So you can go to the t table and then you can find that using the degrees of freedom, that means we use the 25 measurements, that means sample size was 25, and then that means 25 minus 1, that means for 24 degrees of freedom, what would be the z critical value? You have to find that. Let me show you. So again, you have to draw the distribution, and then you will find, you will see that we are going to use we are going to try to find the value for 0.975, the t critical value. The other value 0.025 is not here. So you know this is a bell-shaped curve, and then we can use the same value, the positive and negative, for 0.025 and 0.975. So for degrees of freedom 24, the t value is 2.06. Okay, so that's what we, let's go back. That's what we use, negative and positive 2.06. And then you can see that the t statistics value using the sample size, sample mean, using the population mean. That's what we said in the null hypothesis, and we use that, and then we actually use the sample standard error, and then you can see we found negative 1.48. And if I use negative 1.48, if I draw the distribution, let's draw it again. Okay, so I'm drawing that, and if I draw, then the negative 2.06 and positive 2.06, these are the two critical values we have, and then where the negative 1.48 falls. So negative 1.48 may be somewhere here, that means falls within the acceptance region, within this region. That means we are not going to reject the null hypothesis. Okay, that's why we say that it's the null hypothesis. That means we are not going to reject that. That means this is, it could be 10. So that's why we say that not significantly different than 10. So in this video, you learned how you can write down all the steps in hypothesis testing. So these are the 7 steps we have to follow. Write down the hypothesis, and then write down what's the significance level, and then what's the critical region. You have to find that. You have to use the t or z table for the mean, and then you have to decide on by drawing the distribution, and then drawing the acceptance and rejection region. Then you can say that whether the null hypothesis is rejected or accepted. And then whenever we are making the inference, we have to say that the null hypothesis is rejected or the null hypothesis cannot be rejected. And then we saw that whenever we know the population mean, population standard deviation, then we can use the z distribution z table. And then whenever we don't know, that means we don't know the population standard deviation and sample size small, then we have to directly go for t test and then use the t statistical table. So later I will show you how you can use for 2 population. That's it for today. Thank you.